MongoDB for giving us this nice space, so thank you very much. So I just have two goals. We'll see if we achieve them. One is to give you like maybe a 3-minute overview of our application, and then the second one is I'm going to try to show you some code. And the code is not going to be like the latest one dot whatever sexy feature in Rust. It's going to be very practical. I have a system, I have some business logic, I want to get that business logic in a system so I can actually start to make some money and deliver functionality to my customers. It's going to be very, very practical. So let me jump in. And we'll, just, I think if you can hold questions to the end, just because, code is a little bit kind of sequential, but I'll try to get through as much as I can. So first, let me start with what our app is. So our app is it's, as it says here, it's a platform for sales and trading to allow for seamless workflows, scalable pricing and risk, and then low latency execution. That's the objective. We don't do that all today. We're a pretty small startup, so we've really just focused on one particular place, which is in the securitization market. And the securitization market, we started there because, if I know many of you are in finance, but probably a bunch of you are not, it's the absolute least electronic of any market ever. It's massively voice-based, there's lots of email, so it's much lower hanging fruit for a technology company to be as well. So this is the first thing that we're looking at, trying to improve. I don't expect you to know what all this is, but I'll walk you through our app, and then maybe you can start to see what some of it is. Of course, I don't know where to put my app. Oh, here it is. Okay, so this is the main screen of our application, and I'll give you this 3-second overview of what the securitization market looks like. So when a client, right? So if you take so Mongo, I'm sure has some sort of pension. That pension fund typically invests in bonds, right? Because they're a little bit safer, less volatile than equities. So if a pension fund wants to sell, because maybe they want less U.S. real estate or whatever, for whatever reason, right? What they do is they put them together in something called a BWIC, which stands for a bid wanted in competition. And it's very, very simple. It's just a portfolio of bonds, and they send it out to usually between 10 and 20 dealers, and they run an informal auction. All right. So in this example here, this is some made-up client named Fisher, and you can see they want to sell 4 bonds for, I think, dummy data from last week. 2 weeks ago, so May 8th, and these are the 4 bonds we wanted to sell. So very, very simple. So today, what happens in many places is, and this is what this other thing is showing here. When a client wants to sell these 4 bonds via this BWIC thing, right, this ad hoc auction, it's just this big pain of a process. They got to send an email out, and then the trader anonymizes it, and then they send it back out to sales. And they send it back out to sales because they want their clients to bid on it. The interesting part is in here. This is where you're actually putting a price on the thing, right? And so, if I go back to for a second here. So what will happen is, a trader will say, I think this bond should trade at, let's say, like an $80 price or a $95 price or 101 or whatever it is. The jargon that's called is called price prop here. Right? So there's a whole bunch of features that we've built in to try to make this process very easy. All right, very easy, very seamless. I'll give Adam a shout out. This little icon here means we have computer sign data for it. So we try to get a ton of information into the system so that you can, as a trader or a salesperson, if you're a salesperson, have a very intelligent conversation with your client, and the trader can price it very quickly. So the part of the code that I want to show you today, there's a lot of code behind this. The part of the code that I want to show you today is really, really simple, right? Again, my objective is just to show you kind of a front to back thing. But it's really scalable, which is why we chose Rust. And so I'll start here. So the thing I want to show you is how we can pump in large amounts of product data into the system. And then any trader or salesperson or data scientist or anybody else can pull in that information as additional properties of these bonds. So I'll show you this again in very, let's see. Of course, you'd think I would have it ready, right? That would make more sense. Okay, so this is like a simple, okay, so this is a simple sample product data file. So in practice, this would be like, a couple million rows, right? Probably a few gigabytes. So that's why the scaling is so important. And oh, sorry. So each row represents some properties of these bonds. And just, you could have as many rows as you want. And the third one is the one that is actually relevant. And what I'm going to, hopefully if I made everything run correctly, you'll see this update, this prop 1. And it's just a simple CSV, right? So you can see in the second column, I changed it from 20 to 21. And let's see where I put it on this. Okay. Yeah, okay, great. So we were able to move a number from point A to point B, right? It's amazing how much code it takes to do that. So this is what I want to show you, right? Very, very simple. And I think the key point to take away here is how do we structure this in Rust to make it happen. Right? Okay. And then I have some bigger examples, which I will likely totally run out of time, but if I don't run out of time, we can go through those. Okay. Is this big enough? Is this remotely big enough? I'm trying to make it big. Okay. I think this is okay. All right. So what I did was, and if you have a laptop, if you go to GitHub and you go to Mies Jansen /presentations, all of this is on GitHub. So you can just look at it, and if you find this useful, just go upload it. Our product is not open source. I took a bunch of our code and I rewrote it for this purpose. Okay, so just to give you an idea, there's actually a lot more when you go to production, but I tried to get as much as I could. So let me again, I'm going to try to go through this quickly. There's only 5 files, all right? And I'll start with main and then kind of walk you through, how it works. So we use Rocket to do this. If you're in the Rust community, I'm sure you know about Rocket. Sergio's, a great supporter of Rust, and he built an amazing networking application framework. It's really, really powerful. Probably a little hard to see at the back, but I'll pull it up. All right, so very simple. So you do Rocket launch. You add your routes, which you could think of as like your microservices, your normal HTTP REST calls. And then the first thing we do is we get some state. And Rocket has the ability to manage state. And so you can very quickly store anything you want in it. So we put our database connection pool into it, our Mongo connection pool. So let me start, I'll start there, since that's probably the easiest part of the code. Okay. So this is pretty close to real. The only thing that I took out of this database code is the security features, right? So anything that does the user identification and user permission. That's not because I didn't want to show you. I was happy to show you. I just ran out of time typing. It was really helpful. So very simple. It uses if you did the quiz from earlier, right? It uses one of those ARC thingies. It goes out and gets the client pool. I'm using the Mongo C driver. If you look it up, I'm not yet using Sam's driver because I I need the thing to be super fast. Sam, am I allowed to say this, Sam? I think this is okay.
I know what you're going to say.
So I actually wrote the whole thing against Sam's Mongo Rust driver, and I was about to go to production, like 2 days away from going to production on it, and it ran great on Mac and Windows, like perfect. And then I went to Linux, and I had a 40 millisecond delay, which in your world would be like monumental. But even in my world, it's a disaster, right? Because basically our app has to operate like a chat tool, which means you have 75 milliseconds, right? So I think for most people, they probably wouldn't notice 40 milliseconds, but for us, it was like game over. So over like a long weekend, I had to group all this down and put this in. So I'm looking forward to the new Rust driver. But the C1 has served me, the C1's very fast and it's served me very well. So pretty simple. We go out, we get the pool. We use the rest of the utilities straight from the Mongo C driver that's wrapped in Rust. And now we have our database pool ready. Okay, so if I go back to the name. So then the next thing is the actual, highlight this. The next thing is the actual function that does the product upload. And this, I had a 15-year gap between programming, so I know a lot happened in the middle, but this is just so clean. Like, this is just, so I want to have, this REST endpoint, and what this says, so this is very straightforward, right? This is what you type in your browser, right? And then this right here is, the data says that to Rocket, I want to stream the data in. And for me, this is critical because I need to stream in gigabytes. All right, so it may seem like a boring little thing, but when I pull in the stream, obviously it takes no memory. Right, it only takes the memory of whatever thing I'm processing at that point. So then I just go and use it here. This is a Rocket data type. IntelliJ doesn't really get all of the Rocket, because Rocket uses nightly, so it doesn't necessarily have all the types right. But anyway, so it pulls this in, and then I can just use that stream, right? So very easy. And then this connection, Rocket does another really nice thing, which you can implement this from request here. Rocket will automatically go out and call that from request, and then give you back the object, right? So I can pop, this is the state that I said earlier in Rocket, and then I can pop off the connection here. So I know I'm kind of fast. If you've already written this, I'm probably going slow, but again, hopefully it gives you a flavor that it's just not that much code is really what I'm trying to get to. Okay, so now I have my database connection and I have my stream. So the only thing I don't have is the permissions. Right? Again, I left that in the production system. I don't have that here, but really everything else I have is there. Okay, so now we have our data coming in, right? Just as a reminder. Right, as a reminder, it was this data. All right, just a little CSV, this thing here. Okay, so now, so this is where all the real work occurs, and it's just barely not big enough to fit. So this is super simple, right? This right here, this line connects my stream into my iterator. And again, we have to be at zero memory, right? Like we have to be as close to zero memory as possible because we want to stream in all this gigabyte of data, right? So I take in the stream, and this package is really nice CSV parser. So great, one line, right? I need headers because I need to know what my data is. I keep a count. This is a queue. I don't want to pound the data into Mongo. I want to group it up before I ship it out to Mongo, so I do that. This I'll get to in a second, and the last one is just an ID. Okay? And then in the for loop is again, I think if you read it for a minute, it's not hard. Right? The for loop is I create a document, right, that I'm going to ship out to Mongo. I put in just some basic setup stuff, right? Like the submission name is just, you want to know who's actually putting the product data in. You want to have a timestamp. Again, in production, I have some other bits, but this is the bulk of it. And then here, I definitely cheated for the demo. So here, I'm just literally just taking from the CSV record and jamming it right into the document, right? Just very boring. In production, it's the same, except I allow for very sophisticated metadata, right? So you can tell me, this is a CUSIP, right? Or you can tell me, this is some complex bond type, and I can use Saturday or Rust machinery to handle it, and it's still machine code and still ultra fast. So I didn't have time to get it all in here, but it's awesome. So I cheated here just to save some time on the demo. And then this is where the real work is, so I'll skip it for a second. And then that's basically it, right? All that happens at the bottom is once you get to 1,000 documents, it writes into the database, right? So very easy. So the last thing I want to show you in the code is this section here where I do this product ID get. That's the last thing I'll show you, and then hopefully I'm not too over on time. So before I do that, I want to tell you why that's important. So each of these bonds, they get updated generally monthly, give or take. And so what you need to do as a system is you need to link them, all right? And so you could use the industries as something called QSIP. You could use bond name, but different securities have different identifiers, and it's all kind of a mess. So you need your own internal identifier, right? But the problem with that is that means you actually have to link. You have to link some data that came in a month ago to the data that came in today, right? So it's not rocket science, but the problem is that I'll go back here. Okay, so the problem is that if somebody gives me, a million rows of data, right, and they're stringing it through. So this thing is set up for. This machine here is set up for 8 threads and 2 processes. So 16, it has 16 effective engines that can jam data in. The problem is that if you're getting the same ID from multiple engines, you need to make sure you're returning back the same product ID. All right, so basically the same product goes in parallel. You need to do the normal kind of threading checks and work to make sure that you're not getting 2 IDs back. I think I explained that about as poorly as you possibly could, but hopefully you got the gist of it. So it's much easier in the code. Right? So basically what I do is I say, okay, I have some product, right? Let's say it's bond 1. Right? So bond 1 comes in, I look at my product table, I see if it's there. Right? In production, I look at an in-memory cache. Right? This is kind of slow, but whatever. Right, so I check to see if it's there. If I see bond 1, and then I get the crystal ID for it, and then I'm done. Right? So, and what I love about Rust is it's like extremely easy to read, but it still generates back to machine code. So then if it's not there, then I have to lock it. Right? I have to say, okay, I'm in charge of generating a crystal ID for this bond 1 or whatever, right? Bond X. Right? And that's where there's actually some work. Right? So first I have to create a new text, right? I'm sure most of you have worked with these, right? So in Mongo, I'm really looking forward to Mongo 4.0 because they'll have transactions. I don't have to deal with any of this anymore, but I couldn't wait that long. But for now, basically, I have to have this big block of code to deal with it. So the first thing I do is I create a new text, which is basically me saying I'm going to be adding a crystal ID for this bond. So that's what this first block does here. If you haven't used the Saturday serialization, deserialization library, it's amazing, right? So to add this record into the database, all I have to do is say, I want this to be something I'm going to serialize out. I specify the fields I renamed one because Crystal requires it with this name. But from that, all I have to do is say, translate it into a Python document, and I can jam it right into Mongo. And that, in my experience, and again, I don't have experience with a million different languages, but that's crazy fast. Right? Both from a typing point of view, from a speed point of view, and it has perfect type safety. Right? So to achieve all those things in one package, I was just absolutely blown away by it. Okay, so now I get my mutex in, right? The other thing that I don't want to spend too much time on is, but Rust really forces you to handle the errors properly, right? Like I think in a lot of languages, errors are just either strings or you've got this big try-catch mess. Here, all I do is I map the error from a Mongo error to an IO error, so the IO error can be bounced up to the user, and then you put a little question mark on it, right? So, it's so painful to read code in another language where you get this big try-catch block, and here instead of question mark, right? It's far more efficient. And Rust is constantly helping you, reminding you, handle these errors. And the last thing I'll say is these map errors, they're all run lazily, right? It's the functional programming style, so they take up zero CPU unless the error is actually called. So it's really nice. So this is all just to get the mutex in. Once the mutex is in, I use the unique index on the collection to make sure that I know the unique index is atomic today. You probably use packages that take advantage of this as well. So I use that myself. So if there is an error and that error is a unique index violation, I know somebody else is trying to add this product into the database. So the first thing I do is I go back to the product table and check to see if somebody already added it. And this is basically, this whole section here is that handshake of, I could read through it all, but if you've done credit coding without actors, kind of old school credit coding, this is the standard kind of handshake to make sure that you've locked your mutex, double check to see that the data hasn't been changed while you were locking the mutex, and then releasing that mutex out. So I won't read through all of it. This part down here is if I didn't get an error, right? So I didn't get a unique index error, I know I own the mutex, right? So again, if I know I own it, I still got to double check and make sure, did it get into the table while I was locking it. So that's really the only complexity. Once it's done, right? Any of these okays send the data back up to here, right? So now I have my Crystal ID, this guy, and then this variable here I use just to tell. So when I go to write the products actually into the product collection, that's also when I clear out the mutexes. So that's just a little convenience to save a few cycles to basically not bother clearing out the mutex collection if there's nothing in it. So that's it. That's the whole thing. Right? Not too complicated. But what's great about it is that with Rocket, it automatically threads it. Right? So I don't do any work to get the threading. It's trivial to spin up, more processes and run these on different machines, and it scales massively. The only thing that I've been able to break on it is, and this is not a use case I think I need to worry about, but if I have like 100 writers writing at the same time on the same, on like 8 CPU machine, it just runs out of connections. And so I'm sure I could tweak, open files or something to be able to do it. But our real use case is somebody pumping in large amounts of data with, say, 30 processes in parallel, not hundreds and hundreds. So I can run, maybe at the end, I can run, I have a script that lets me scale these things out, and I could show you if there's time. So the last thing I'll show you is, if I just go back to the slides quickly. Okay. Just quickly, the system requirements. So we wanted it to be like a chat tool, even though it's not a chat tool. We wanted it to feel like a chat tool. We want on the back end to be able to handle, call it 15 terabytes of data and not have to change any of the code. So I think we've achieved that. I can get it, you can see we want to be customizable and safe and all this other stuff. Again, I'm sensitive to the time. I'm sure I'm over, but if people want to grab me later, we can talk more about this. Our original architecture, you can see here, was very based around Meteor. It was and is excellent. We're still very, very dependent on it. I've been massively happy with it. But there's nothing like actual machine code to get amazing speed. Right? So that's why we went with Rust. Again, I'm sensitive to the time, so I don't want to. I can probably talk for 4 hours on this slide. These are my personal opinions. I'm sure everybody disagrees. I'm sure nobody agrees with them. But these are my personal opinions on how we chose the language. It was, I thought really, really long and hard about which language we should use, and again, this is what I came up with. So again, I'm happy to talk to you about it more. I went through some of these as I was going through the code. I love the results framework within Rust and options. I think it's amazing. Coming from a C++ background, working with other libraries is just a disaster, right? Like you're constantly getting angry. And this is trivial, right? So I made, for the CSV, I wanted some of the latest features from the CSV library. It's trivial to just go pull those. Tests, I personally am really bad at writing tests, but Rust makes it so easy. You actually end up writing a lot of them. So just a lot of nice stuff. I mentioned Survey. Survey is pretty incredible. Documentation's excellent. When you look at Rust, it's actually written in Rust. Like there's a lot of languages. Like Python has a lot of C and some other stuff. Go, I think I looked in GitHub. I think about 10% of Go is assembly. So I mentioned this, some of the stuff that I had a little bit of trouble with. And then I have it on the GitHub page as an appendix if you're interested in how securitization actually works. Am I out of time? No?
I think
Okay, I have 2 minutes for questions. I'm being told. Yes, sir. You're the winner.
Yeah. For testing this, I have just never tested like database stuff with Rust or Mongo for that matter. How do you did you just have like full integration tests with an actual database running, or are you mocking that out? Like how are you doing that?
Let's see. It's so I have we wrote a script, which I can show you. Somewhere it's in here somewhere. I don't know where I put it. This is.
it's dropped in the Slack,
Oh yeah, that's a good point.
Join the Slack, they'll put it in the Slack channel.
Yeah.
Hashtag
It's
NYC
alright if you don't have it right now. That's fine.
So this is what I used to test the demo. It's pretty similar to what I used in production. Like I generated a ton of data, right? I mean, I took this out. If I was going to run it during the demo, the RAM is actually pretty slow. But basically, what this does is, it lets me very quickly. So I ran last night 922,000 rows of data, which is simulating like products being added. It took 18 minutes on my my little laptop with kind of unoptimized. And I just so I said 2 engines, 8 threads, 62 parallel jobs, 5 columns, 100 rows. So it spans it out and then jams it. So the one thing I want to do is set up like maybe I'll set up like an Amazon Lambdas array, right, and then fire that off at it, and I think that'll be pretty solid.
So I saw you had like a struct set up for the data and you have types against it. Is there a canonical like validation library in Rust? So like for example, like QSIP is going to be 9 alphanumeric characters. The first 8 are letters and numbers, and the last one is a check digit that's a function of the previous 8. Is there a standard way of doing that in Rust? Not just saying this is a string and matches a Or even if you just say it's a string, but it must match this regex?
Yeah, so the way it's a good question. So what I've been doing is using this survey thing, the serialization, deserialization, because it has, as part of that, you have to check, everything's coming in. Do you know Sam or Scott or Sam? Do you guys know?
You can hook into Survey, like basically define like a custom validator. But
That's what I'm doing. I did it right. Without asking Sam. Thank you. Come on, yes.
Yes. How did you achieve that amazing performance when you updated something on the server side and it updated on the client side instantaneously? So do you have active socket connections? Because it seems very easy, but it's extremely hard to do that in an application that needs to ensure transaction integrity.
Yeah, no, thank you. Yeah, I think what we did, I think we did two things, right? So we separated the transaction piece of the database from the kind of the real-time chat piece. And then from a technical point of view, everything is connected to WebSockets. Okay. So there's no polling, there's no refresh. It's all pushed directly into the browser. If you don't do that, obviously it's a disaster.
Yeah.
All right. Yeah. That was it. Thank you. Am I good? All right. Thank you. Thank you.